we want to find the limit. The limit as x approaches infinity of the square root of 9x squared plus x minus 3x. So let's go ahead and write that out. We have the limit as x approaches infinity of the square root of 9x squared plus x minus 3x. Okay, so the first thing we want to do is to get rid of that radical sign. And so in order to do that, we're going to multiply the numerator and denominator by its conjugate. So this is over 1, and we're going to multiply the numerator and denominator by its conjugate. So we're going to multiply it by the square root of 9x squared plus x plus 3x over the square root of, again, 9x squared plus x plus 3x. So now let's go ahead and multiply that out. So we have the limit as x approaches infinity. So in the numerator, when we multiply this, we multiply it with the difference of squares. So when we multiply the first two terms together, when we multiply them, it's going to remove the radical, and then what's left is 9x squared plus x. And then we have minus, well, 3x times 3x becomes minus 9x squared. And then in our denominator, we have the square root of 9x squared plus x plus 3x. Okay, now let's combine like terms in the numerator. So when we combine like terms in the numerator, we can see that 9x squared minus 9x squared is going to give us 0. So we have x over the square root of 9x squared plus x plus 3x. Okay, now our next goal is that we want to be able to divide this by x. So what we want to do is we're going to multiply the numerator by 1 over x. And we're going to multiply the denominator also by 1 over x. So let's see what happens when we simplify this. We end up getting the limit as x approaches infinity of x divided by x over, we have the square root of 9x squared plus x over x plus 3x over x. And again, that's from distributing the 1 over x. Okay, so let's go ahead and simplify here. So we have the limit as x approaches infinity. Okay, what's left in our numerator is 1. And then we're going to deal with this square root of 9x squared plus x over x. Okay, so what we want to do is we want to make sure that the denominator can also be within a root for us to be able to make sure that we can divide what's inside the radical. So I want you to recall that if you have 1 over x, okay, well, can we get to that 1 over x if we take 1 over the square root of x squared? Well, yes, we can, because 1 over the square root of x squared becomes 1 over x. And now, since we are going to positive infinity, we can use the positive version of the square root of x squared. So this means that we can actually divide this by the square root of x squared. And so then we can share the actual denominator. So it becomes 9x squared plus x divided by x squared. And now we end up getting 9x squared divided by x squared plus x divided by x squared. So what we've noticed now here is that because this has a radical, we can now rewrite this in a denominator as here the square root of 9x squared over x squared plus x over x squared, and that's plus 3x over x, which is 3. Now let's simplify what's under the radical. So we have the limit as x approaches infinity of 1 over the square root of, well, that's 9x squared over x squared, which is 9, plus this is 1 over x plus 3. Okay, now let's go ahead and apply the limit as x approaches infinity. So we have 1 over the square root of 9 plus, well, this is 1 over infinity, which becomes 0. So that's 9 plus 0, and then plus 3. So we have 1 over the square root of 9 plus 3. We know the square root of 9 is 3 plus 3. So therefore the result is 1 over 6. Okay, so let me go back to this part right here just so that you might need an extra understanding on this. Okay, if we have 1 over x, okay, we can square the numerator and the denominator. So that's 1 and that's x. So therefore we get 1 over x squared. And then we can also take the square root of the numerator and the denominator, which means you would end up getting 1 over the square root of x squared. So 1 over x is equal to 1 over x squared. So we can divide the radical by the square root of x squared, so we can eliminate the first term, so we end up with a constant. So these are just things that you would want to know or need to know when you're dealing with algebra. So algebra is a big part of solving these limit problems.